Welcome to the deep dive. We are really thrilled to have you with us today. I want you to consider just for a moment the absolute pinnacle of armored warfare.
Right.
You're looking at a 70-ton steel behemoth. It's equipped with a devastating cannon wrapped in this impenetrable composite armor, and it's capable of tearing across completely unforgiving terrain at highway speeds.
It's the ultimate apex predator of the modern battlefield.
Exactly. Now, what if I told you that the very word we use to describe this fearsome weapon, the word tank, is actually a massive, century-old historical accident?
Oh, yeah.
Literally a bureaucratic cover-up designed to hide a top-secret weapon from prying eyes.
It really is one of the great ironies of military history, a term that commands such universal respect and fear today. It started out as nothing more than a mundane diversionary tactic, just to fool enemy spies.
And that's exactly the kind of surprising, totally contradictory detail we're going to be exploring today. Our source material for this deep dive is an incredibly comprehensive Wikipedia article. It details the sprawling history, the intricate engineering, and the tactical evolution of the tank.
And there is a lot of ground to cover.
So much ground. But our mission here is straightforward. We are taking this massive, dense history of armored warfare and distilling it down for you. Think of this as your shortcut to being completely well-informed. We're leaving the overwhelming jargon behind.
No engineering degrees required today.
Right. We're just focusing on the most fascinating aha moments. We want to uncover how these metal fortresses shape the modern world and what their grueling development reveals about the absolute limits of human engineering. Okay, let's unpack this.
To truly grasp the significance of the tank, you really have to look past the internal combustion engine. You have to realize that the core concept is ancient.
The idea didn't just pop up in the 20th century.
Not at all. The fundamental desire to provide troops with mobile protection and heavy firepower, that goes way back. If you look at the Han Dynasty, around 119 BC, General Wei King utilized what were known as armored wugang wagons.
Oh, wow.
Yeah, he deployed them in these ring formations against nomadic cavalry, effectively creating mobile cover for his archers. And then, moving forward to the late 15th century, you have Leonardo da Vinci.
Of course, Da Vinci had a hand in this.
He always does. He drew up elaborate plans for a conceptual precursor to the tank. His sketches showed this man-powered wheeled vehicle. It was sloped to deflect fire and surrounded by cannon.
Though, as our source points out, trying to propel a heavy wooden and metal fortress purely with human muscle inside a tiny, poorly ventilated space.
Yeah, a bit problematic in execution.
More than a little problematic.
Mm-hmm.
But the dream of an armored land ship persisted. And I love how science fiction actually predicted the future here. Long before anyone successfully built a functional modern tank, H.G. Wells wrote about them.
In 1903, right.
Right. A short story titled The Land Ironclads. He envisioned armor-plated machines just driving relentlessly across entrenched enemy positions.
It's a striking image. But while Wells's fictional machines relied on steam power, the real-world breakthrough that ultimately made tanks viable was the continuous caterpillar track.
Which didn't even start as a military invention.
Exactly. The origin of that specific technology is a brilliant example of cross-pollination. It wasn't designed for artillery. It was engineered to conquer snow.
I love this part.
The engineer Reginald Skelton developed caterpillar tracks for the explorer Robert Falcon Scott. This was for his 1911 Antarctic expedition. They desperately needed a method for motor vehicles to traverse the soft, shifting snow of the Antarctic landscape.
Because regular wheels just sink right in.
Precisely. The continuous track distributes the weight of the vehicle over a much larger surface area. It significantly reduces ground pressure so the vehicle stays on top. Fast forward a few years to the outbreak of World War I, and that exact same weight distribution principle is precisely what you need
to cross the muddy, cratered wasteland of no man's land on the Western Front.
Which brings us to the urgent birth of the machine itself. By 1915, the British High Command realized they needed a revolutionary method to break the brutal, grinding stalemate of trench warfare. So Winston Churchill, serving as the First Lord of the Admiralty at the time, formed the Landship Committee.
But because they're developing a weapon that could potentially turn the tide of the entire war, operational security was paramount. They needed a cover story.
A very boring cover story.
Right. They're building these enormous tracked weapons, and they need a non-threatening name to put on the shipping crates. Something that makes enemy spies yawn and look the other way entirely.
At one point, the committee proposed referring to the vessels as a water carrier. The cover story they fabricated was that they were manufacturing new mobile water receptacles for Russian troops on the front lines.
They almost labeled the crates water carriers. Fortunately, someone realized that stamping WC across their top-secret wonder weapon meant they'd be sending their troops into battle inside giant armored toilets.
A slight oversight there.
Yeah, British slang would have ruined the whole intimidation factor.
Yeah.
So they pivoted to a slightly less embarrassing, equally mundane moniker: tank. They literally labeled the crates tanks, trying to pass them off as giant snowplows or liquid containers. And the name just stuck permanently.
It really is wild. And you have to consider the psychological impact of their debut. It is September 1916 at the Battle of the Somme. The British deploy the Marka tanks.
These were massive, right?
Oh, massive diamond-shaped metal boxes creeping across the mud. The enemy had absolutely no context for what they were looking at.
The source actually includes this incredible quote from a 19-year-old signaler named Bert Cheney. He witnessed this debut. He described seeing huge mechanical monsters such as he had never seen before. He noted that they rumbled onto the battlefield, frightening the enemy into scuttling like rabbits.
It was a paradigm shift in real time.
But while the British invented the tank, it was actually the French who perfected the blueprint we still recognize today.
That's true. Those early British tanks looked like giant rhomboids with cannons awkwardly protruding from the sides. They called them sponsons. But in 1918, the French introduced the Renault FT light tank.
And this changed everything.
It did. It introduced two profound innovations. First, it placed the engine in the rear compartment. Second, it featured a fully traversable 360-degree rotating turret mounted on the very top of the hull.
And that specific configuration is so undeniably effective that it remains the fundamental blueprint for almost every single tank manufactured around the globe today. It separated the crew from the intense heat and deafening noise of the engine and gave the main gun an unobstructed field of fire.
A total game changer. And as we move from that early development into the interwar period and World War II, the doctrines surrounding these machines underwent a radical transformation.
We're not just moving at walking pace anymore.
Exactly. We transitioned from tanks moving slowly merely to shield advancing infantry to the devastating implementation of the German Blitzkrieg tactics.
Blitzkrieg. Lightning War. The German tactician Heinz Guderian famously declared, "Where tanks are, the front is."
They utilized concentrated masses of armor, and crucially, they equipped them with two-way radios. They worked in tight coordination with dive bombers and motorized infantry to punch violently through enemy lines.
It introduced a level of tactical flexibility and speed that simply shattered traditional defensive strategies.
But the source highlights a fascinating contrast in engineering philosophies during World War II. It became a war of industrial attrition and competing design priorities.
Quality versus quantity.
Precisely. The Germans focused on building apex predators, the Tiger and Panther tanks. These machines were high quality, heavily armed with high-velocity guns and thickly armored.
But there's always a catch.
Always. They were also incredibly complex, very prone to mechanical failure, and painfully slow to manufacture. Against them, you had the United States and the Soviet Union taking a completely different approach.
The U.S. built the M4 Sherman and the Soviets built the T-34.
Right. And on a one-to-one basis, these tanks often struggled against the heavier German armor, but their brilliance lay in logistics. They were reliable, relatively simple to repair in the field, and vitally, they could be mass-produced on an unbelievable scale using standardized parts.
The logistical superiority cannot be overstated. When a complex German Tiger tank broke its transmission, it often had to be abandoned or shipped all the way back to a railhead. When a Sherman or T-34 broke down, standard parts could be swapped out by field mechanics almost immediately.
The numbers are staggering. By May 1945, the U.S. had built around 42,000 Shermans, and the Soviets produced up to 65,000 T-34s. They overwhelmed the sophisticated German engineering through sheer industrial capacity.
And the scale of the resulting clashes is difficult to wrap your head around. Mentioning the Battle of Kursk in 1943, it stands as the largest tank battle ever fought. We're talking about nearly 3,000 tanks on each side, colliding in a grueling war of attrition.
And studying the destroyed armor from battles like Kursk forced engineers back to the drawing board. It repeatedly highlighted the inescapable dilemma at the core of all tank design.
So what does this all mean? When you strip away the historical battles, what is the actual physical limitation engineers are fighting against when building these machines?
It comes down to a concept military engineers refer to as the iron triangle. Every single tank ever built is a negotiated compromise between three competing factors: firepower, protection, and mobility.
You can't have it all.
The fundamental reality of physics dictates that you cannot maximize all three simultaneously.
It's somewhat like the old adage about buying a car. You can have it fast, cheap, or reliable, but you only get to pick two.
Exactly. If you want maximum protection to survive modern weapons, you have to add thicker, denser armor. But adding all that weight severely degrades your mobility. Your engine strains, your fuel consumption skyrockets, and your vehicle might become too heavy to cross standard bridges.
Or navigate soft terrain without sinking.
Right. Now, if you prioritize firepower, you need a larger caliber cannon. But a bigger gun requires a larger, heavier turret to support the recoil, which, again, adds weight and slows you down. Conversely, if you want lightning-fast mobility, you have to strip away the heavy armor, rendering the tank highly vulnerable to enemy fire.
It is an endless game of technological, budgetary, and tactical trade-offs.
It really is.
Moving past World War II and into the Cold War, Armies stopped trying to field separate classes of light, medium, and heavy tanks. They consolidated those roles into what we now call the main battle tank, or MBT.
The objective was to engineer a versatile powerhouse that struck the most lethal possible balance within that iron triangle, and the engineering leaps required to push those boundaries are staggering. Modern main battle tanks operate on an entirely different level of power.
Take the propulsion systems. The American M1 Abrams tank doesn't even rely on a conventional diesel engine. It houses a Honeywell AGT 1500 gas turbine engine.
It's unbelievable.
It's essentially a modified helicopter engine strapped into a ground vehicle, outputting 1,500 horsepower. It can push a 70-ton block of steel up to 45 miles per hour across paved surfaces, though it does consume gallons of fuel per mile to achieve that.
And it isn't just about raw speed on flat ground. It's about traversing environments that defy logic. Fording is a prime example.
Right, driving through water.
Most tanks can wade through a meter of water, but modern tanks like the Russian T-90 or the German Leopard 2 utilize deep wading snorkels. They can drive entirely submerged beneath 3 to 4 meters of water.
That is terrifying.
The crew remains inside, navigating the riverbed while relying on a slender tube reaching the surface for engine air intake and crew oxygen. It allows them to bypass blown bridges and flank enemy positions from completely unexpected angles.
Wow.
What's fascinating here is how the evolution of tank armor mirrors a biological arms race. It is a constant escalating cycle of action and reaction between armor developers and anti-tank weapon engineers. During the Cold War, standard rolled steel armor quickly became obsolete.
Because the weapons got too good.
Because of two distinct threats. Kinetic energy penetrators, which are essentially dense, ultra-fast flying metal darts, and shaped charge warheads.
A shaped charge isn't just a regular explosion, right?
Correct. Instead of just blasting outward in all directions, a shaped charge uses explosives to invert a copper cone. This creates a hypervelocity jet of molten metal that essentially cuts right through solid steel like a blowtorch through butter.
So if standard steel was failing against these new molten metal jets and high-speed darts, how did engineers protect the crews without just piling on more steel and making the tank too heavy to move?
They had to innovate. The British developed chobham armor, which is a composite. Instead of just thick steel, it utilizes layers of ceramics and plastics suspended in a resin matrix, all sandwiched between steel plates.
So it's a layered defense.
Yes. When a shaped charge hits it, the ceramic layers shatter, absorbing and disrupting the energy of a molten jet. But perhaps the most radical innovation was explosive reactive armor, or ERA.
I love this concept. Wait, explain how they intentionally strap explosives to the outside of their own vehicles.
I know, it sounds utterly counterintuitive, but if you mount small, brick-like boxes of explosives on the exterior armor, you can defeat a shaped charge. When the incoming anti-tank missile hits one of those ERA bricks, the explosive inside detonates outward.
Outward toward the missile.
Exactly. It forcefully throws a metal plate directly into the path of the incoming molten jet, disrupting its focus and dissipating its energy before it can penetrate the main armor underneath.
You are literally using a controlled explosion to deflect incoming explosion. That is just incredible engineering.
But of course, anti-tank weapons adapted. Engineers developed tandem warheads. This is essentially a missile containing two separate explosives in sequence.
A 1-2 punch.
The first, smaller explosive triggers the tank's reactive armor brick, detonating it harmlessly out of the way. Fractions of a second later, the second, primary explosive detonates, punching its molten jet right through the newly exposed bare armor.
So once the armor could be tricked, The defenses had to evolve into the realm of science fiction.
They did. We moved from passive armor waiting to be hit to active protection systems, or APS, like the Israeli trophy system. This is what the industry calls a hard kill system.
How does that work?
The tank is equipped with small radar panels that constantly scan a 360-degree dome around the vehicle. If they detect an incoming rocket or missile, the onboard computer calculates its exact trajectory in milliseconds.
Faster than humanly possible.
Much faster. It then automatically fires a focused, shotgun-like burst of projectiles to intercept and destroy the threat in midair, yards away from the hull.
It swats supersonic missiles out of the sky before they ever touch the paint. That's wild. But for all this incredible high-tech weaponry, the source grounds us by focusing on the human element. At the end of the day, there are people operating these machines. The physical reality of being inside a modern tank during combat is something few of us can truly comprehend.
It is a profoundly intense sensory overloading environment. Most modern tanks operate with a crew of 4, and their survival relies entirely on seamless, unspoken teamwork.
Imagine sitting in there.
Right. You have the commander, positioned highest in the turret with the best panoramic vision devices. They are responsible for directing the tank's movement, identifying targets, and maintaining situational awareness of the broader battlefield.
And below them, you have the gunner, peering through thermal optics, constantly calculating trajectories, and dealing with wind shear and target movement to fire the main cannon.
Then you have the loader, who is performing intense physical labor in a highly confined space. They're repeatedly pulling heavy shells out of stowage and shoving them into the breech of the gun while the vehicle lurches over rough terrain.
And finally, the driver, isolated down in the hull, navigating this massive machine while looking through narrow periscopes.
Add to that the smell of cordite from the fired rounds, the suffocating heat of the electronics in the engine, and the bone-rattling vibration of 70 tons of steel moving cross-country.
Sounds exhausting.
It is. Furthermore, a huge portion of a tank crew's time is actually spent outside of combat, performing grueling, heavy maintenance just to keep the tracks tensioned and the turbine running. It takes an immense physical toll.
So with all of that in mind,
This raises an important question. With all the logistical strain, the massive costs, and the vulnerabilities we've discussed, are tanks becoming obsolete?
right, if a cheap commercial drone dropping a grenade or a relatively inexpensive shoulder-fired RPG can destroy a $10 million Abrams tank, why are militaries still spending billions developing them? Doesn't that make the tank a massive, slow-moving liability on a modern battlefield?
It is arguably the most hotly debated topic in military science today. The 21st century battlefield has shifted heavily toward asymmetric warfare and complex urban combat.
Like we're seeing in current global conflicts.
Yes, in recent conflicts, such as the Russo-Ukrainian War, we've seen the devastating proliferation of cheap anti-tank guided missiles and first-person view drones. The calculus of war has fundamentally changed when a multi-million-dollar asset can be neutralized by a vastly cheaper weapon.
So why keep them around?
Because nothing else on the battlefield can do what a tank does. Engineers and tacticians aren't abandoning the concept of mobile protected firepower. They are adapting the doctrine.
It's evolving.
Exactly. The source emphasizes that the days of tanks rolling unsupported across an open plain are over. To survive today, a tank must be integrated into a highly coordinated combined arms network.
So they can't go it alone anymore.
Never. It relies on dismounted infantry to sweep urban areas for anti-tank teams. It relies on electronic warfare vehicles to jam drone frequencies. And it relies heavily on air support. The tank is the hammer, but it needs the rest of the toolkit to function.
Here's where it gets really interesting. Because the research and development for the next generation of tanks is pushing the boundaries of what a vehicle can even be. We're looking at hybrid electric drives.
It would be massive.
It would make the tank vastly more fuel efficient, drastically reducing that massive logistical burden we talked about. And critically, it would allow the tank to operate almost silently on battery power during stealth approaches.
They are also prioritizing signature management. Not just painting the armor with camouflage patterns, but integrating active systems designed to cool the exterior. They want to blend in with the background temperature, masking it from enemy thermal optics.
Literally trying to make the tank effectively invisible to radar and infrared sensors.
They're even testing electrothermal chemical guns, using plasma to ignite the propellant to get unprecedented velocity and range out of the main cannon.
That is just sci-fi material right there.
They are attempting to finally conquer that iron triangle. Instead of just adding heavier armor, they are utilizing advanced electronics, stealth materials, and network-centric warfare to ensure the tank sees the enemy first, shoots first, and remains completely undetected.
As we wrap up this deep dive, let's take a step back and appreciate the sheer trajectory of the journey we've just been on. We started with ancient commanders using armored wagons and H.G. Wells dreaming up land ironclads. We saw Winston Churchill's committee nervously disguise a top-secret weapon under the mundane label of a water carrier.
And the toilet joke that saved the name.
Yes, the WC disaster avoided. And we traced the evolution from those terrifying, slow-moving metal rhomboids creeping across the Somme all the way to 1,500 horsepower, radar-equipped main battle tanks that use controlled explosions to defeat incoming fire and swap missiles out of the sky.
It's an incredible evolution.
Why does all of this matter to you? Because the tank isn't just a weapon of war. It is the ultimate physical manifestation of human engineering, continually pushed to its absolute breaking point by the brutal, unforgiving necessities of survival and strategy. Every weld, every composite layer of armor, every microsecond calculated by an active protection system represents a massive leap in what our industrial and technological capacities can achieve.
If we connect this to the bigger picture, you really have to wonder where this evolutionary arms race actually leads us. We are rapidly moving toward a future focused on hybrid engines, stealth materials, and digital networks, linking armored vehicles with infantry squads and aerial drones in real time.
The battlefield is evolving into a giant interconnected web of data, and the tank is just one node in that network.
Precisely. So here is a final thought to ponder as we conclude. If the future of tank design is entirely focused on making the vehicle invisible to radar, eliminating its thermal signature, and plugging it into a massive digital network of automated systems, will the tank of the late 21st century even be a heavily armored manned vehicle at all?
That's a profound question.
Or will the relentless quest for the ultimate battlefield advantage eventually force the tank to evolve into an autonomous, decentralized swarm of unmanned machines? We might very well be looking at a future where the 70-ton, heavily armored behemoths of the past are rendered entirely extinct, replaced by a synthetic swarm we can barely conceptualize today.
An autonomous swarm replacing heavy armor. That is a wild, slightly terrifying thought to leave on. Thank you so much for joining us on this deep dive. We hope you walk away today feeling a little more informed and deeply fascinated by the incredible history, the engineering trade-offs, and the sheer human ingenuity behind the tank. Until next time, keep exploring the details.